All this time, we've basically been doing one thing. We've been taking some assumptions, combining them with some data, and drawing some conclusions. So in general, we have this equation. Assumptions plus data yield conclusions. And we can learn a lot of things from this equation, actually. One is that if we have some data and we make stronger assumptions, then we can get stronger conclusions. So think about noncompliance in randomized experiments, like the Oregon healthcare experiment. There we saw that 70% of people did not comply with their assigned treatment. And we saw that if we make the strong assumption that people are randomly choosing to comply, then we get the strong conclusion that we learn average treatment effects exactly. But if we make a weaker assumption that we don't know the nature of noncompliance, then we get a weaker conclusion. We could only learn bounds on the average treatment effect. Okay? Now similarly, if we have stronger data but weaker assumptions, then we can also get stronger conclusions. So in that Oregon healthcare experiment example, suppose that we didn't have any noncompliance. Okay? Nobody violated what they were assigned to. Everyone did what we told them to do. That would be stronger data. And we saw that if that was the case, if we had this stronger data, then we would get the stronger conclusion that we would learn average treatment effects exactly. Okay? Now, there's another way of thinking about this equation, and that's that if I have stronger data, I can make weaker assumptions to get the same conclusion, okay? As long as they balance out. We saw this with panel data. Remember that panel data is when we have data over time. We observe the same person for multiple years, for example. Now this panel data is stronger than cross-sectional data, where we just observe a bunch of people once, because we can always delete time periods from our data set and just whittle it down to a single cross-section. So panel data is strictly richer than cross-sectional data. And when we talked about panel data, we saw that you could relax the assumption that your treatments are independent of all confounders in their levels, okay? And instead, all we had to do is assume that changes in treatment status over time were independent of changes in confounders, okay? Whereas if we only had cross-sectional data, we had to assume that the level of treatment status is independent of all unobserved confounders, of the levels of unobserved confounders. So with stronger data through panel, we were able to get away with weaker assumptions and still learn about average treatment effects.